Hey, we're going to start off this section 13.2 with a little bit of a quick review. So 13.2 is where we're headed today, but let's see if we can do these 6 trig values. So our theta is right down here. This would be the opposite. This is the hypotenuse. And of course down here would be my adjacent. I used the Pythagorean to get that, of course. Sine 12 squared minus 8 squared, square root of 80. And I simplified that to 4 square roots of 5. So the sine of any angle, the opposite over the hypotenuse. In this case, 8 over 12 is your sine, opposite over hypotenuse. Your cosine, E2 is going to be adjacent, which is 4 square roots of 5 over our hypotenuse of 12. And our tangent is opposite over adjacent, which would be 8 is our opposite. Our adjacent, 4 square roots of 5. We have a little work to do on these now, so let's simplify them. So this guy here is going to go to 2 over 3. This guy here is going to go to the square root of 5. 4 and 3, 4 thirds, or 4 over 12 goes to 3. So square root of 5 over 3. And this guy here is going to end up being 2 over the square root of 5. So sine, opposite over my hypotenuse, which is 8 over 12, goes to 2 thirds. Cosine is my adjacent, 4 square roots of 5 over my hypotenuse of 12, which simplifies down to the square root of 5 over 3. And your tangent, which is your opposite over your adjacent, which would be 8. Now we do probably need to rationalize that tangent, so let's go ahead and do that by multiplying by the square root of 5. And that guy's going to end up being 2 square roots of 5 over 5. So we do need to rationalize these, so make sure you take care of that. So the other values, the other trig values then, will be sine, cosine, tangent. What goes along with the sine is, of course, cosecant. And that is just going to be that guy inverted, isn't it? So it is going to be 3 over 2. That is your cosecant. Your secant is going to be this guy inverted. So when we do invert that, we're going to end up with 3 over the square root of 5. So then we'll rationalize, and I'm running out of room here, but we're going to end up with 3 square roots of 5 over 5 after we rationalize. Your cotangent again, we'll be inverting this guy. Now we might want to just go right back to here, and that's pretty easy. We don't need to rationalize, we can just invert it right back to there. So your cotangent then is going to be equal to the square root of 5 over 2. So went back to where we inverted, or where we rationalized, and just got that done right there. So not too bad for us. All right, the 45, remember the ratio? It's going to be x. This is going to be x. This side is x square roots of 2. So let's solve for these two legs. Remember, they're going to be the same. And we're going to take x square roots of 2, set it equal to 60. Divide by the square root of 2. We do need to rationalize. So we're going to end up with 60 Square roots of 2 over 2, and of course 60 and 2 simplify down to 30 square roots of 2. So the length of both of these are both 30 square roots of 2. Just getting through a couple things from 13.1. Our last little problem here is the helicopter. I do have the answers down underneath here, so you can always check those if you care to. See if I can get it to go open myself. Here we go, a couple answers for you. So the helicopter looks like our answer we know. So we do want to draw a right triangle here. And its altitude is 4500. Angle of depression from the plane to the helicopter, okay? And the distance between the two. So we're looking at 27.6 here. So of course our distance that we're looking for is this height right here. So use, we want to find, we have the opposite here, and we want to find the hypotenuse. And opposite of our hypotenuse is my sine, of course. So the sine of 27.6 is 27.6 is equal to the opposite, which is 4500 over my hypotenuse, which I don't know. You will need your calculator here. Make sure you're in degree mode. And grab that calculation. My 7 didn't turn out too good over there, so not easy to write. All right. Hopefully you're able to get there. And let's get to today's lesson, and that is angles of rotation. So a couple things we're going to do. We're going to draw angles in standard position, which is pretty easy. And we're going to be finding some trig values for an angle in standard position. So I think you'll catch on pretty good. So let's get to it. Standard position, a couple of terms here: initial side, terminal side, angle of rotation, coterminals, and reference angles. So we'll get to all those just to give you a little precursor to where we're headed. And those are little words that's going to come up today. So 13, we investigated trig. We evaluated some other angles. So an angle in standard position is when the vertex is at the origin and one ray is on the positive x-axis. So an initial side of the angle is always a ray on the x-axis. The other ray is called a terminal. The terminal is going to be the one that we're going to be moving. Give you a good look at what that means right here. So a positive rotation, we have our initial side, which is right here. And our terminal is going to move. So that is a 135 degree angle. We can also have negative. So the initial side is always going to start on the positive x-axis there. And we can rotate these around many times, okay? So example, we can bring this thing down around here and stop it right here and have a 270 degree angle, okay? So we can keep this negative one coming all the way over to here and stop it here and have a negative 180. So we can go around many times as we want, and these are going to be called coterminal, as you'll see here in a second. So angle of rotation, we can go all the way around. So really, we start on the initial side, rotate all around. So it's 360 degrees, went another 30, and we can have an angle of 290. But the reference angle is a 30, and you'll learn that the reference angle is the quickest way back to the x-axis. Quickest way back to the x-axis. So, real simple. Draw an angle with a given measurement in standard position. So, we'll have our coordinate, xy coordinate here. All right. We're going to start on the side right here, 45, puts us right there, and that's how simple this is. Let's do another one. This time negative. So negative, we're still starting with our initial side here. That would be negative 90. And we're just approximating here, negative 135. You don't need to get out a measuring device and try to do it exactly. 210. It is a positive 210. So let me get a different color there so you can see it. So we're starting here. Of course, that would be 90. There is 90. That is 180. 210 puts us down in this neighborhood right here. All right. There you have it, drawings in standard position. Hopefully you feel just fine about that. Do another couple quick ones here. 210. Again, I'm going to start right here. That would be 90, 180, 210. This is an interesting one, 385. So let's take a look at that one because it is a full time around and you need to think about that. So it's still going to start here. 160 and then up a little bit is 385. So the reference angle there would be the quickest way back to the x-axis. So what's the quickest way back to the x-axis here? The quickest way back to the x-axis is right here. And what is that angle there? Well, it is a 25-degree angle. That would be your reference angle. All right, I'm going to let you do 300, negative 300. It's going to be negative going the other way. Reference angle for negative 300 would be a positive 60, though. All reference angles are positive. All reference angles are positive. Moving on, coterminal. If you see coterminal, you need to think 360 degrees apart, okay? So notice here, 120 and negative 240. So positive 120 starts here, heads this way. Negative heads this way. They share this terminal. That's why they're called coterminal. They share that terminal side. So that's pretty simple right there. If I ask you to find coterminal, you're basically going to add and subtract 360. So if I have, and I'm asking you to find a measurement of a positive angle and a negative angle that is coterminal here, you're just going to take 65 and you're going to add 360. So if we add 360, we're getting 425. And if we minus 360, we're getting negative 295. We can just keep going with as many as we want. There's an unlimited amount of coterminal angles. It is infinite amount. Infinite. We just keep adding and subtracting 360 till the cows come home. And you got it. Coterminal. There you have it. 360 apart. I think if I go back to this guy right here, this helps you see really what coterminal means. They're sharing this terminal side here. So that can be anywhere on this circle where they're sharing that size. 360 apart. So again, you're going to add 360 and subtract 360 and get your positive and negative coterminal here. Same with here. I think we're good with that. Again, positive, add 360 and subtract 360. All right, that's getting to the easier stuff. Reference angle, I've been talking about it. Just remember, we see reference angle, quickest way back to the x-axis. So let's say this was our initial side coming over here. Let's say this is 120 degrees. So my reference angle will be back down to this x-axis. Of course, that's a $1.80. So that means my reference angle would be 60 degrees. 60 degrees there. That's a lousy 60. So let me fix that guy. So again, back to the x-axis as fast as we can, wherever you may be. Let's practice a couple reference angles now. Okay, so we want to draw out. And we're going to have our angle starting initial, coming around to 135, approximately right in here. My quickest way back to the x-axis is right here, this way. This is 180. So my reference angle is, of course, a 45. Let's try this one over here, negative 105. Okay, so negative 105, starting here. That would be negative 90, negative 105. Again, we're approximating this, negative 105. But I'm trying to get back to the x-axis as fast as I can. And that's going this way. And what is that going to be? That's going to be 75 degrees. Now notice that is positive. All reference angles are positive. Reference angles are going to be positive. What do you think? Reference angle. Quickest way back would be here. If we were to draw our axes. Right. 35 degrees. Because 35 and 325 give me that 360 that I'm looking for to get back to that x-axis. Now you might start to think about them without even drawing them out. 105. 105. What would be the reference angle of 105? Well, I'm going to head back down to 180 there, so it is 75 degrees. And 115, of course, would be 65 degrees. So those of you still a little bit, make sure as you look at your Cartesian, this would be 0 or 360. Up here, of course, is 90. 180 here. 270. 360. We can just keep rolling. So hopefully that helps you with those right there. Last thing today is a point. We're going to give you a point, determine the values of your sine, cosine, and tangent given a point. So we're going to get right to this, and I'll let you look at this for a second. It's y over radius, x over radius, and y over this sine, cosine, and tangent. But it is the same as SOHCAHTOA. So then your sine is obviously your opposite over your hypotenuse. Your cosine is your adjacent over your hypotenuse. And your tangent is your opposite over adjacent. Just same thing here, but we're going to be using our unit circle and our point. So let's get right to one of them and see what we're talking about. So I'm giving you a point on the coordinate plane. And there she be. So we'll plot that point. We're going to go ahead and plot that point on our axes. And the first thing we're going to try to do is get that hypotenuse or that red line. Well, I went ahead and figured it. Of course, think about that. This is -6. Your x is -6. And your y is 9. So 9 squared plus -6 squared. That's going to be positive. So we're going to end up with after you simplify it, this hypotenuse is 3 square roots of 13. Now your angle is your reference angle, closest way back to the x-axis. Remember, we're coming kind of like that, closest way back. So this would be your opposite side. This would be your adjacent side, and you know that's the hypotenuse. So almost what we started off with today. You plot the point, find the hypotenuse, and that's always going to be positive. That hypotenuse is always going to be positive for you. So now we're ready to do our trig functions here. So my sine. My sine is going to be my opposite, which is 9, over my hypotenuse, which is 3 square roots of 13. Let's go ahead and fix that up. It's going to end up being 3 over the square root of 13 after we have 9 over 3. Then we're going to rationalize, and we end up with 3 square roots of 13 over 13 as your sine. Your cosine. Your cosine, of course, is adjacent, which is -6 over 3 square roots of 13. That can simplify to -2. Okay, that can simplify to -2 over the square root of 13. We'll go ahead and rationalize now. And we have -2 square roots of 13 over 13. There is your cosine. Your tangent. Your tangent here is going to be your opposite over your adjacent. So it's going to be 9 over -6, which will simplify to -3/2. So there's your sine, cosine, and tangent. We'll go ahead and get the other 3 trig values now. So sine. So what goes along with sine is, of course, the cosecant. So cosecant and sine are going together here. I'm going to go right to here because right before I rationalize, so I can just invert that, and it's going to be the square root of 13 over 3. And there's your cosecant. Your cosine goes along with your secant. And that would be this guy right here. And that, we're going to go right back to right here before I rationalize. And so we're going to end up with the square root of 13 over 2, and it will be negative. Hopefully you see why I'm going back right before I rationalize. That way I don't have to do it again. If I started with this over here, I'd have to rationalize, which I don't really feel like doing. I can just go back to the other spot. And then our last guy, of course, is our cotangent, and we can just invert this right here. So our cotangent of that point is going to be -2 over 3. So again, let's review. You got your point. You're always going to find your hypotenuse. It is always going to be positive. Find your reference angle. Figure out where opposite is. And walk through your 6 trig values there. All right. Yeah, I think there were the answers for some of them. You can go ahead and look at them on the. Remember, R is always going to be a positive number. So I'm going to move on and let you finish out this guy with a couple of those right there. Good luck. I know you'll do well. You guys are doing awesome, getting your grades, getting your homework in, and hopefully some of these videos are helping you a little bit. Talk to you soon. Thanks.